Dr. J. Raja Paul Perinbam, Professor of ECE, KCG College of Technology, Chennai. He has completed his BE Electrical Engineering from Madras University and has done his MSc Engineering in Applied Electronics. He has also completed his PhD in IIT Madras. He has specialized in electronic circuits, microprocessor and embedded system, power electronics and VLSI design. He has over 32 years of teaching experience in Anna University, Chennai. He had worked as a professor of ECE and head of the Department of Media Science in College of Engineering, Guindy. He has guided 16 research scholars. He has also participated in 12 international and 3 national conferences. He has published 31 international journals and 5 national journals.
Welcome to the UGC lecture series. We are going to see now the subject Microprocessor I. So, first of all, let us see about the introduction to the microprocessor and what is microprocessor. So, in this lecture we will see about what is microprocessor and what is the language of the microprocessor, namely the machine language and the assembly language. So, microprocessor, as you see here, is a integrated circuit. It will look like this. So, if you open a microprocessor IC, it will look like this. You see here a coin, a $1 coin. So, it is so small and contains millions of transistors. So, it is an integrated circuit containing more than, of course, sometimes of course it contains the latest processor contains even billions of transistors. So, it will look like this. So, microprocessor is basically a computer on a single IC. So, let us see the brief history of the computer. So, before the advent of the electronics, so the computers were made by using the mechanical component. Okay, so, this was the computer made by Charles Babbage. So, it was called as the difference engine. So, it had 25,000 parts, and you see here the photograph of this computer and the cost of the computer you are seeing here. So, this was the computer that was built when there was no electronics. Then electronics came in 1900 or so. So, vacuum tubes, at that time there were vacuum tubes. Okay. So, these vacuum tubes relied on the flow of electrons in vacuum. So, there is a heater inside which will heat a surface and electrons will be emitted, and flow of electrons will be controlled through a control grid. And using these vacuum tubes, the computers were then built, and in 1946 the first electronic computer was built in University of Illinois. So, you see here the first electronic computer that was built in 1946. So, you can see here it is so huge and it consumed kilowatts of power. Then came the transistor revolution in 1948. So, in 1948 Shockley and his team they invented the transistor. You see the first transistor made by Shockley and his team in Bell Laboratories, USA in 1948. Okay. So, that started a new revolution, and the transistors replaced the vacuum tubes. So, vacuum tubes, they had lot of disadvantages, like they need higher voltages, higher power, and it consumed more space. So, all these disadvantages were removed by using the transistors, and this may look that the transistor is very big, but actually this was the first transistor. So, this was the first transistor, and so therefore, at that time the technology was such that it looks big. So, later on as the technology advanced, the size of the transistor became smaller and smaller. They were able to make number of transistors on a single silicon, and Jack Kilby, he made about 10 or 12 transistors on a single silicon crystal, what you see here, and he made the first integrated circuits. What he did was, he combined transistors and resistors, okay, on the same silicon die, and he made a integrated circuit. So, instead of transistors were integrated, and complete circuit, say a digital circuit like a AND gate, NAND gate, flip flops. So, they were made. So, this was the first integrated circuit. So, this also, as you see here, looks quite big. So, at that time the technology was not that much developed. Then technology was developing rapidly, and they were able to reduce the size of the integrated circuit. So, you can see here the first the commercial integrated circuit made in 1960s. So, this NAND gate, okay, this circuit was made by Motorola Corporation. So, this is the circuit of a NAND gate. Then using these integrated circuits and then transistors, the IBM made computers. The 1960s, the computers were like this. So, they are called as mainframe. Still the computers are quite big, and they were quite expensive. Then of course, another revolution came, that is the size of the transistors were systematically getting reduced, and metal oxide semiconductor transistor was introduced. The metal oxide semiconductor transistor was invented in 1928, but at that time people did not bother much about the metal oxide semiconductor transistor. So, later on it was found that the metal oxide semiconductor transistors can be made in smaller size compared to the previous transistors, and it consumed less power, and Intel developed the technology, and they were able to integrate, as you see here in this slide, 1000 transistors in 1971, and they made the first 4-bit microprocessor, that is Intel 4004. So, this is the photograph what is inside a 4-bit microprocessor. It contained 1000 transistors, and the frequency of operation was 1 megahertz. So, that really started things rolling, and people were improving the technology further and further, and they were pushing more and more transistors inside, and then Intel made 8-bit microprocessor, that is 8008 and 8083 and then 8085, and in 1975 the first computer, a small computer, as you see here, appeared using this microprocessor, that is a computer on a chip, as you see here in this photograph. So, let us now see the basic concepts of a microprocessor. What is microprocessor? So, microprocessor is basically a computer fabricated on an integrated circuit. So, we saw the computers fabricated by using mechanical components, and then vacuum tubes, and then transistors, and then different integrated circuits. So, all these computers were very big, okay, and very expensive. So, as the technology advanced, they were able to make the computer on a single integrated circuit. So, the microprocessor was born. Of course, in 1970 it started, and every year performance is improving. So, it is basically a computer on a single IC. So, the integrated circuit means, what is meant by integrated circuit? So, it is a small silicon chip. So, the size is very small. The size will be, as you see here, size of your fingernail. We have technology to fabricate millions of transistors, okay. So, by fabricating millions of transistors, we can put the entire computer in the size of your fingernail. So, what is transistor? So, transistor is electronic component, okay. So, in these integrated circuit, transistors are used as a switch. So, in digital electronics, you would have already studied about digital electronics, we have only two states, 0, 1. So, the 0, 1 is realized by using a transistor, either the transistor is on or off. So, using the transistor, we can create zeros and ones, okay. So, electronically it can be controlled, and the entire digital system can be very easily realized, okay. How the word microprocessor came, okay. So, microprocessor, it has got two words, that is micro and then processor, okay. Micro means what? Micro means very small. Processor means it processes something, okay. So, microprocessor processes data. Data in microprocessor is represented by zeros and ones, okay. So, it cannot process any data. So, it can process only digital data, that is zeros and ones, okay. So, what is the process? Process means you are manipulating something, okay. So, you are performing some operation, you have a data. So, you are performing some operation on the data. What type of operation? You can perform arithmetic operation, you can perform logical operation. So, arithmetic operation means we have case addition, subtraction, multiplication, division, and logic operation is AND, NAND, NOR, inversion, XOR, and so on. So, a microprocessor can take the data okay, in as ones and zeros, and it can perform any of these operations. Okay. So, either it can perform logic operation or it can perform arithmetic operations. Okay. So, let us now have a formal definition of a microprocessor. So, I have explained about what is micro, what is processor. So, now let us have a formal definition of a microprocessor. As you read here, a microprocessor is a programmable device. Okay. So, it can be programmed as per our requirement, okay, to perform the process in a particular way, and it takes numbers. Numbers means numbers has to be represented by binary number only, and it does arithmetic and logic operation. So, in what way it has to perform the operation? Okay. So, we have to give the instructions to the microprocessor to perform the operation. So, the instructions are called as program. So, these programs are stored in the memory location. So, the programs are stored in the memory location. So, the microprocessor takes the program that is stored in the memory location and performs whatever operation you want that processor to do. So, let us now study the definition in more detail. So, we have seen the formal definition. So, previous slide. So, same thing I am repeating. Now, let us see the definition word by word. So, it is a programmable device. Okay. What is the meaning of the programmable device? Okay. So, programmable device, it performs set of operation on the data in a sequential manner, okay, using the instruction you are supplying. Okay. So, we have to supply the instructions what operation it has to do. So, it keeps on performing the operation. Suppose you change the program, the operation also will change. Okay. So, anytime we can change the program and we can change what type of operation, you can decide what type of operation you have to perform. So, the sequence of instruction is called as program, and the microprocessor can be programmed to do that particular sequence of instruction as per our requirement. Okay. So, by changing the program, we manipulate the data in different ways. So, in whatever way you want, you can do the manipulation by changing the program. Same definition I am repeating. So, operations. So, again you read it. Okay. Microprocessor is a programmable device that takes the number, performs them arithmetic or logical operations. Okay. So, what is meant by operations? Okay. Operation means each microprocessor is designed to execute a specific group of operations. So, I already mentioned the operation means it does arithmetic and logic operations. Okay. So, they are called as the operation. So, they are designed to perform these arithmetic and logic operations. So, these operations, so your command to, so your the group of operations, they are called as instruction set, and your commands for the microprocessor to perform the operation, they are called as the program. So, the group of operations, so these logic operation, arithmetic operation, and then data transfer operation. So, all these things, so they are called as the instruction set. Okay. So, this instruction set, okay. So, a microprocessor can strictly follow only the instruction set that has been decided already by the manufacturer. Okay. So, so different companies are making microprocessor. So, in this subject, as per your syllabus, you are going to study about 8085. So, there are other processors are also there. So, Motorola 6800. So, as per the manufacturer's whatever he has designed, accordingly it will perform the instructions. So, let us now have a short break and let us meet again. Welcome back after the break. So, we were seeing about what is meant by operations. Okay. So, a microprocessor can perform different type of operations, and this group of operations, they are called as instruction sets. Okay. So, the operations are mainly arithmetic, logic operation and data transfer operation. We will see about all those things in the coming slides. Okay. Then again we see microprocessor takes in numbers. What is meant by takes in? Okay. the microprocessor has to take the data to manipulate. Okay. So, the data has to come from somewhere. Okay. Take in means it has to take in the data. So, microprocessor cannot hold all the data. So, the data has to come from somewhere. So, the data that the microprocessor manipulate must come from somewhere. From where it comes? Okay. So, it comes from input device. So, a microprocessor will be connected to a input device. So, the data has to come from the input device, and these devices they are meant to bring the data from the outside world. Okay. So, you require data has to be brought from the outside world, and through the input device it has to be sent to the processor. Okay. So, what are the, you would have already seen about various devices that take the data to your computer. Of course, your computer also contains a microprocessor. Okay. And these, what are the devices? You already know: keyboard, a mouse, switch, and so on. Okay. So, these are some of the input devices that take your data, okay, to the processor. Okay. Then we say that the microprocessor takes numbers. Okay. So, numbers means, so the microprocessor understands only binary number. Number means it is not a normal decimal number. The microprocessor can understand only binary number. So, it takes binary number. Okay. So, it takes number as a group. Okay. So, the group of numbers, not single ones and zeros, a group of ones and zeros. So, this group is called as a word. Okay. So, a 4-bit, a group of ones and zeros, 4 numbers of ones and zeros in a group, it is called as a nibble, and 8 bits together, it is called as a bit. So, the microprocessor what you are going to study, 8085, of course, the other microprocessor 6800, etc. Okay. So, 8085 is the processor we are going to study. They process number as a group of 8 bits as a byte. Okay. So, the advanced processors like 8086, 6800, they can process 16 bit together. So, 16 bit number is called as a word. Okay. Then you have long word, we have ARM processor and other later processors, they can process group of 32 bits. So, 32 bit is called as a long word. Okay. Then again I am repeating the definition. So, it performs arithmetic or logic operation. So, what is meant by arithmetic and logic operation? So, arithmetic operation means I already mentioned that it is addition, subtraction, and of course, 8085 cannot do multiplication, division. The other processors can do multiplication, division also. Okay. Then the latest processors can perform multiplication and division. Then apart from this arithmetic operation, they can also perform logic operation, AND or XOR, then shifting left, shifting right, and so on. Okay. So, the arithmetic and logic operation means, so these are the arithmetic and logic operation a processor can do. Okay. Then again coming to the definition of the microprocessor. Okay. So, the microprocessor performs and according to the program stored in the memory. Okay. So, what is memory? Okay. So, memory is a definition for a memory. It is a location where the information is kept while not in use. Okay. So, you have to keep everything ready for the processor. Therefore, you need some storage mechanism. Just like if you want to write an exam, you read and store it in your brain, and then whatever according to the questions that is asked, you write the answer. So, to write the answer, you have to store it somewhere. Of course, you have to store it in the memory. Same way, microprocessor has to process the data, means it has to store the data somewhere. Of course, the data where it is stored is called as the memory. Okay. Whenever it is required, it is taken from the memory and they are processed. So, the storage devices, they are grouped into 8 bits. So, since the 8 bit microprocessor processes data 8 bit at a time. So, these ones and zeros are stored in storage devices as a group of 8 bits, and number of 8 bits. So, one 8 bit is called as 1 byte. So, like that a microprocessor memory contains can store of the order of kilobytes, megabytes, and nowadays our processors that are used in our desktop and laptops, they have memory gigabyte and so on. So, apart from data, the program that has to be executed by the microprocessor, that is also stored in the memory. Okay. So, that is also stored in the memory. So, the memory stores information in binary form in a group of 8 bits, that is as a byte. So, the group total number of data that may be stored in a microprocessor will be of the order of kilobytes, megabytes and gigabytes. Okay. And apart from data, program also is stored in the memory. Then again you see here, so after storing the program and processing, it produces something, it produces some other data. So, you add something, you get say 2 plus 2, you add, you get 4, like that it does something and produces some other data. Okay, it produces. So, what it produces? Okay. So, it produces the result. Okay. So, after execution of the program, it produces the result. So, you are adding two numbers and you get the answer, that is the result. So, that result has to be presented in such a form that it is useful to you. So, in a readable form. Okay. So, the result has to be presented in a output device. Okay. So, the microprocessor, if it keeps the result in the memory in the form of 0 and 1, it is not of any use. So, it has to be presented in a readable form. Okay. So, using an output device, same way in our desktop and laptops. Okay. So, there is a microprocessor, it and the data, everything is stored in binary form. So, it processes everything in a binary form, but we cannot understand all these things. So, what we can understand is the decimal number, alphabets and so on. So, it converts it into a readable form in the presence in the output device, a monitor, a printer and so on. So, it is presented in a output device, and as you see here, this can be a monitor, a printer and in LED, LCD device and so on, many other such devices. Okay. So, now let us see the block diagram of the microprocessor. Okay. After all this introduction, you should be now able to understand the block diagram as it is shown here. So, this is the microprocessor. So, it processes the data. So, for processing the data has to be stored somewhere. So, it requires memory. So, you can see here so this is the processor for processing the data. So, this is a integrated circuit as I already mentioned. Okay. Then you have the memory. So, memory also of course integrated circuit. Okay. So, it stores the data as ones and zeros, and so you can see the arrow going this way as well as that way. That means what? So, the microprocessor can take the data from the memory, process it and then again send it back to the memory, store it back to the memory, and it can also process the data, and you can see the arrow in this direction, that it can send the data to the output device also, a monitor, printer and so on, and then it has to receive the data. So, you see the arrow in this direction. Okay. So, it can receive the data from a keyboard or from any card reader and so on. Okay. So, this is the input. So, input device, output device and the memory you see arrow in both the direction, because microprocessor can receive the data, process it and send it to the memory. Okay. So, this is the block diagram of a microprocessor based system. Okay. Now, what is inside the microprocessor? Let us say, so this is a complete, what we saw in the earlier slide is a complete system. Microprocessor along with all these things makes a computer. Now, let us see the microprocessor alone. So, what is inside that microprocessor? So, okay. So, inside that microprocessor we have 3 units. Okay. So, the first is the arithmetic logic unit. Okay. So, arithmetic logic unit is the one that performs all the arithmetic and logic operation, and then the control unit. Okay. So, control unit is the one that is responsible for controlling the arithmetic logic unit. So, it has to decode the instruction and tell the arithmetic logic unit whether to add or subtract or shift or multiply and so on. So, the control unit generates all the control signals. So, it has to tell when to read the memory, when to send the data to the output unit and all those things. And then it also contains little amount of memory inside the processor itself. So, previous slide we saw that memory. So, we have a memory here, but microprocessor also has got a little few, maybe less than 10, okay, 10 locations, okay, less than 10 locations. So, that memory is called as registers. The memory inside the microprocessor is called as registers. So, they hold the data. Okay. So, data that has to be manipulated. So, it cannot be every time coming from the main memory. So, that will take a lot of time. Therefore, microprocessor generally manipulates data, 2 data at a time. Okay. So, add means it will add 2 numbers. Suppose even if you want to add 100 numbers at a time, it will add 2 numbers, then another thing like that only it does. So, whatever that has to be manipulated immediately, that will be transferred to the memory inside the processor. That it has got an array of memory, that of course only very small number only. So, they are called as registers, and they hold data that are being manipulated. So, that is what is inside the microprocessor. So, now let us see the block diagram of the microprocessor, what is inside the microprocessor. Okay. So, as I told you, so this is what is inside the microprocessor. So, arithmetic logic unit and a small amount of memory there, that is called as the register array, and a control unit. So, this is the one that has to control what the arithmetic and logic unit has to do, and then after processing it has to be sent to the input output devices. So, data generally consists of 8 bits. So, for each and every bit there will be one line. Okay. So, one electrical connections. Okay. So, they are called as the bus. Okay. So, this bus will connect the memory, input output device and so on. Okay. So, this is the processor, and then this is the input output unit. So, the data 8-bit processor means 8 lines will be there, 16-bit processor means 16 lines, 16 connections will be there. So, these connections together 8 or 16 or whatever maybe, they are called as the system bus. Okay. So, this is the detailed view of the microprocessor based system. Okay. Now, let us see what is meant by memory. Okay. Memory stores information in binary form, that is in zeros and ones. Okay. So, this is the one that gives data to the microprocessor. Okay. So, in a microprocessor use different types of memory. Okay. So, memory is a general term, but in processor again we will go in depth. Okay. So, what are the type of memory that is being used in a microprocessor based system? So, the registers in the microprocessor, so they are also basically memories. Okay. So, small number of registers will be there. So, basically they are also memory. Then apart from that, so program, say the operating system, so that has to be stored permanently. So, that should not get erased. So, you have only read only memories. So, they are called as ROM, and then you have random access memory. Okay. So, in this memory you can store the data and you can manipulate, then again store the new data, and if power supply goes, so whatever data that is there will get erased. Okay. Now, to summarize whatever we have studied. Okay. So, we saw what is meant by microprocessor. Microprocessor is basically a electronic chip. Okay. So, the size is as small as your fingernail, and it contains millions of transistors, and it is basically a computer on a chip. Okay. So, it is mass produced, and because of the technological advancement, it is, although it is very powerful, it is available at a very cheap price. Okay. And then we saw what is meant by formal definition of the microprocessor. So, each and every term we saw about that, what is meant by instruction set, what is meant by programming and so on. And finally, we saw the block diagram of a microprocessor based system, that is so a microprocessor based system contains the processor, and for sending the data it requires the input unit, output unit, and storing the data it requires memory. Okay. And then so what are the kinds of memory that are being used in a processor based system? So, all these things we saw. Okay. So, from the lectures I will give you 3 questions. So, you can please find the answer for them. So, the answers are already there in the slides. So, first question is can you define the words micro and then processor? Then what are the different types of memory that are there in a microprocessor based system? Name some of the input and output devices used in a microprocessor based system. We will continue in the next class in more details about and we will see about what is assembly language, machine language and so on. Okay. Thank you.